Hey, good morning, class. The lesson for this week is angle-circle relationships. Hope you guys had a good Memorial Day. And today we're going to learn two theorems. But before we learn two theorems, I want to teach you some vocabulary. So here we go. Secant line. So if you guys remember, I taught you something called the tangent line. The tangent line is a line that touches a circle at one point. Well, now I'm teaching you the secant line. The secant line is a line that touches a circle at 2 points. So let me show you an example. This line here, we'll name it AB, and this line here, we'll name it CD. These two lines are secant lines. Why? Because they both touch the circle at 1 point. So AB is a secant line, and CD is a secant line. So again, tangent lines touch at 1 point, secant lines touches at 2 points. And secant lines form a certain relationship in circles. So we're going to investigate those two relationships. So one is it creates angles on the inside of a circle, and then it creates angles on the outside of a circle. And we're going to look at both theorems. So the first theorem we're going to look at is angles on the inside of a circle theorem. So let me give you the theorem. An angle formed inside by two lines is half the sum of the intersected arcs. So what does that mean? So let me show you what it means. We draw two secant lines. Okay, so you can see that. And here, one arc is X, the other arc is Y. And in the middle, it's an angle. Now, that letter looks like an O. It's not an O. It's the Greek letter theta. So I'm introducing you to the Greek letter theta. And theta is usually in math is meant for the unknown angle. So whenever we're looking for the unknown angle, we call it theta. So we're looking for notice that you have the two arcs, X and Y, and then the inside angle created by the secant lines. And that inside angle is what we're looking for. So the measure of the inside angle is found by theta equals half of the sum of the two arcs. So what you do is you take the two arcs, you add it together, you take half of that, and that will give you the measure of that inside angle. And it's that simple. So let's go ahead and apply it. Let's go to example 1. Example 1. Find the measure of angle TVU. TVU is angle theta. So again, the formula here is theta equals half the sum of the two arcs. And if you look, let's substitute it. So the left arc is 72 and the right arc is 89. So we substitute it into those spots. So to find angle theta, it's going to be half of 72 plus 89, which is half of 161. Half of 161 is 80.5, and there we go. That's how it's done. Now, if you are confident in this, go ahead and try number 1 on your own. Now again, you can always pause the video and try it, and then unpause to continue. Remember, I'm not going to stop, so you have to pause the video and you can rewind at any time if you don't understand something or you need to see what I did. Again, it's half the sum of the two arcs. So you take the two arcs and you find the inside angle from that. So let's go ahead and look at try 1. Here's try 1. Again, we're looking for the angle AED, which is theta. And theta is equal to half the sum of the two arcs. And again, the arc on the left is 92 plus the arc on the right, which is 109. So we add it up. And 92 plus 109 is 201. Take 201 divided by 2, and that gives you 100.5. And there you go. Try 1 is 100.5. If you got that right, good for you. So let's move on and continue now. Now, I want to teach you secant lines that form angles on the outside. So notice X and Y are still your arcs, while this time, where's the angle? The angle is not inside the circle, it's outside the circle. So in this case, an angle formed outside by two lines and is half the difference of the intersecting arc. So in this case, it's not the sum, it's the difference. And the difference is a subtraction. So in this case, angle theta is equal to 1/2 of the bigger arc minus the little arc. So notice X is bigger than Y on all these pictures. So in this case, it's the sum of the bigger arc minus the little arc. So you take half of the sum of the bigger arc minus the little arc. Again, if the angle's on the inside, it's addition. If the angle's on the outside, like here, it is subtraction. So let's go ahead and apply this theorem. So here, example 2. Okay, we have to find theta, which is that unknown angle, AEB. Again, theta is found by half the bigger arc minus the little arc. Now let's take a look at the picture. What's the bigger arc and what's a smaller arc? So you see theta is going to be half of 103 minus 27. So it's going to be the bigger arc minus the little arc, 103 minus 27, which gives us half of 76. 76 divided by 2 is 38, and there you go. Okay, now it's your turn to try number 2. And again, you may pause the video at any time and try it. So find the measure of the following, DGE. And again, since the angle is on the outside of a circle, you notice it's not on the inside, it's on the outside of a circle, we're going to use the formula for the outside of a circle. So again, the unknown angle theta is found by half of the bigger arc minus the little arc. And the bigger arc is that big arc, 182, minus the little arc, which is 33. Again, half of 182 minus 33 is half of 149. Take 149 divided by 2, and you got 74.5. And there you go. Now, we got 2 more examples left, which is example 3 and example 4. Now, you've learned both theorems, which is essentially it's just the inside angle and the outside angle. Now, this time we have to in number 3, it's not in number 3 and 4, it's not as plain and simple. So let's take a look. Let's take a look at this. It says find the measure of arc MN. So in this case, we're given the angle on the inside and we're given the arc on the left, but we're not given the arc on the right. So what do? Now remember, we have 2 theorems, angle on the inside and angle on the outside. Now in this case, since the angle is on the inside, we're going to use the formula for angle on the inside, which is the addition one, right? Remember, angle on the outside is subtraction. So let's use the formula. Angle theta is equal to half of the left arc plus the right arc, right? So in this case, what do we know? We know the angle on the inside, so we can substitute here. And what is that number we're going to substitute? And then we can also substitute here because we know the arc on the left. So I'm going to substitute here for theta. I'm going to substitute 94. Do you understand why I substitute 94? Because that's the angle on the inside. Equals half of 69. Now, what is it we don't know? We don't know the right arc, so we put mn. Now take a look at the equation that I created from substituting. Okay. Now, what do we do at this case? So the first thing we need to do is we have to get rid of that 1/2. What is the opposite of 1/2? Well, to get rid of the 1/2, you need to multiply both sides by 2. So if I multiply both sides by 2, it cancels the 1/2. So this gives me 2 times 94, which is 188, equals 69 plus mn. Okay, we're almost done now. To find the measure of mn, minus 69, and that gives you 119. So the measure of arc mn is 119. So if you guys understand this, let's go ahead and move on to try number 3. So let's try number 3, and again, you can pause it anytime, try it, and then unpause it. Here we go. Try number 3. Again, what are we given? We're given the angle on the inside, we're given one of the arcs, we're not given the other arc. So here we go. The formula we use, 1/2 of the first arc plus the second arc. So what do I know? I know the inside angle is 133, so I substitute right there. 1/2 of 92, so I substitute right there. What is it I don't know? I don't know what AB is, so I substitute right there. So here, first step is to get rid of that 1/2, and I'm going to multiply by 2 on both sides. That gives me 266 equals 92 plus AB. Minus 92, minus 92, cancel it out, and I get 174. So AB is 174. Okay. If you got that, good for you. Now it's time to move on to the last example, which is example 4. Let's take a look at example 4. Here we go. Here's example 4. Find the measure of FJ. FJ. So again, what is the measure of FJ? Again, what do we know? Notice where's the angle? The angle theta is now on the outside, so we're going to use the outside one. So we're going to use the big arc, half the big arc minus the little arc. Now, what do we know right now? We can substitute here, which is the outside angle, and we can substitute here, which is the smaller arc. We need to find the bigger arc, right? So let's go ahead and substitute what we know. So the angle on the outside is 45 plus 1/2 of FJ, that's the one we don't know, minus 87. Okay? And again, how do we solve this? Get rid of the divide by 2 by multiply by 2 on each side. That gives us 90. 90 equals FJ minus 87. Okay? Plus 87 to both sides. And that gives us 177 degrees. And there you go. FJ is 177 degrees. Now, try the last one on your own. Let's go ahead and try number 4. Again, let's take a look at this. Find the measure of KP. Again, the angle is on the outside this time, not on the inside. Notice that on the outside it forms like a V or an A shape, and angles on the inside form like an X shape when two secant lines form. So again, these two secant lines form like a V shape, which creates an angle on the outside. So here, what do we know? We know the outside angle, which is 23, and we know the little arc, which is which is 36. So we don't know what X is. X would be KP minus 36. So again, get rid of the half by multiplying by 2. That gives me 46 equals KP minus 36. Solve this equation, get rid of 36, add 36 to each side, cancel it out, and you got 82 degrees. So KP is equal to 82 degrees. And there it is, folks. That is your lesson for this week. Good luck, and I hope you guys are having a good time. Bye for this week, and make sure you guys take attendance and sign in and do your work like you're supposed to. All right. Bye-bye now, guys. See you next week.